right, in this video, I'm going to demonstrate how to do part 1 of your project. And that's going to include how to determine the rate and start value from a real world problem, how to write an equation in slope-intercept form, how to brainstorm a realistic domain and range for the function, and how to use the domain and range to set up the graph, how to use the slope and y-intercept to graph the function, and how to use the graph or the equation to make predictions. So here's the problem. Carol owns a t-shirt company. She both designs and produces t-shirts for local individuals, and she paid $18,000 for a printing machine. It costs her, so we're talking about her costs, not her profits, but it costs her an additional $5 for each t-shirt she produced. So we're going to imagine this situation where she's spending all this money to get her business off the ground. Hopefully she's making a profit too, but that's for another lesson. And I'm going to think about, for the start value, well, how much money did she start out spending? Well, she had to spend, even before she started printing t-shirts, she had to start out spending that $18,000. So the start value is $18,000. Her rate is $5 because that's how much she spends for each t-shirt. The word "for each" is a really good clue that this is talking about a rate. That's one clue. Another clue word like that might be per. That's another clue that you're talking about a rate. So our start value is $18,000. I circled the wrong one. So this is why I said to be careful here. I have noticed some folks accidentally switching up the start value and rate in the equation. And so I wanted to just be really clear about that. The start value here is $18,000 and the rate is $5. Because when we write our equation is going to be y equals rate times x plus start value. And another way as mathematicians that we write that is y equals mx plus b. So now on the next screen, we'll write our equation. So we've already determined our rate and our start value. Remember that the m in the equation is the rate. And the b is the start value. And since I determined those numbers on the previous screen, I'm just going to go ahead and type this in. My equation is y equals 5, that's my rate, x plus 18,000. Here's a big, ugly number. They ask me what these mean in the context of the problem. I'm going to say 18,000, or the start value, 18,000 is how much she spends to get her business started before she even prints any t-shirts. The rate, $5, is how much she has to spend per t-shirt. And you can write that kind of part in your own words, just kind of taking this math equation and putting it back into the context of the equation is what we're doing here to figure out her total cost. So we're going to use this equation to make a graph. Before we do that, we're going to take one step back. We're going to think about the domain and range of this equation. Remember that domain is associated with x values. So these are all the realistic x values of a function. And the range is all the realistic y values. The x values we also think of as the independent variable. The y values we sometimes think of as the dependent variable. So these are what's going to go on x and y in the graph. In this case, what's going to go on the x-axis of this graph is going to be the number of t-shirts printed. So our domain would be like, what's a reasonable number of t-shirts? Well, she can't print less than 0 t-shirts. You can't print -2 t-shirts. So it's going to be 0, 2, and then let's brainstorm some numbers. Is she going to print 10 t-shirts? Yeah, but if she's running a business, let's hope she prints more than 10, right? So 100. Honestly, I think she should dream bigger than that. Let's go to 1,000. Even better, let's go to 5,000. But I'm going to stop there. I just don't think it's realistic that Carol, her first time out running a business, would print, excuse me, 1 million t-shirts. That seems unlikely after she's just brought this printer. So let's say 5,000 t-shirts. That would be like the most t-shirts I can possibly imagine her printing. So domain is 0 to 5,000. And the range is how much money she would have to spend in order to print 5,000 t-shirts, okay? So she could spend $0, but actually she couldn't because she's got that start value. So she could spend the least amount of money she can spend is, well, let's put the units here. Let's say t-shirts. And then we'll put the $sign here. This is how much she spends. She spends between 18,000 to, and this is the tricky part. For figuring out the top part of the range, I'm going to go back to my equation and I'm going to think about, okay, well, I know she's going to spend at least 18,000. And then it's plus 5 times the number of t-shirts. If the maximum number of t-shirts she can print is 5,000, it would be 18 plus 5 times 5,000. 18,000 plus 5 times 5,000. So that's 25,000. So that's, I'm going to crunch those numbers here. 18,000 plus 25,000 is 43,000. I think I got that right. So this is the max money. So that means my range is she spends between $18,000 to $43,000. So I was thinking about what numbers are realistic, and that's going to help me when I build my graph also, because and there's wiggle room there. You might have just gone with 1,000 t-shirts for the domain, and that's all right. You'll be able to zoom out on the graph to find those bigger numbers if you need to. All right, so now let's set up our graph, and we're going to use that domain and range we came up with. I'm going to go here to graph settings. I have to move myself over here. Then down here, you'll see x-axis and y-axis. We decided that the fewest t-shirts she could print was 0. So I could put the number 0 there. And we decided that the most t-shirts she could print would be 5,000. But notice how that makes the 0 go right up against the edge of the graph. And that makes the 5,000 go right up against the edge of the graph here. So maybe I think I'm going to make this just a tiny bit smaller. Instead of 0, I'm going to make it -50. And now I can actually see that y-axis, and I can see that where that 0 is, and that's nice. Okay. And then over here, I might just go a little bit above that 5,000 so I can see that 5,000 on the graph. So I'm going to make it 5,500. So now I can see my x-axis goes from 0 to 5,500. So I'll be able to see that whole domain, all of the x values on the graph. My range, again, we started at 18,000. I would actually I could start the graph at 18,000 and go up to we have 43,000. But that means the actual line when I graph it, let's graph that line. Let's throw it in there, and then we'll adjust the domain and range as we need to. It's y equals 5x plus 18,000. I'm just typing it in, using it like the graphing calculator that it is. That's my equation. So I'm just graphing it using that equation. See how it starts the graph here, and it doesn't really show me that it's starting at 18,000. I'm going to go here and I'm going to adjust this and make it 0 so that then I have a better visual of what this graph looks like. I can see how much money she'll make if she prints 500 t-shirts, if she prints 1,000 t-shirts, if she prints 1,500, all the way up to that 5,000 that we estimated would be the most that she could possibly print. Okay. And now that we've got our graph, so that gives us a starting place for our graph. If I had come in here and done all that without changing this domain and range, my graph wouldn't even show up. Right? So if you notice that your graph doesn't show up, the reason your graph did not show up is because you need to go here and adjust the x and y axis to match your domain and range, or to be very close to your domain and range so you can see the whole graph. So now we have a graph to work with, and this is great because it gives us all kinds of information just from reading the graph. We know, for example, that if she prints 1,000 t-shirts, she's going to spend a little over, it's like maybe she's going to spend $2,300 if she prints 1,000 t-shirts. So we'll use that to answer the next couple questions. I'll come back to this graph in a moment. So now asks me, if she produces 2,000 t-shirts, what will be the cost of running her business? Well, let's go back and find that on the graph first, and then I'll show you how to do it with an equation. Okay. So we're looking for, if she prints 2,000 t-shirts, 2,000 is here. So I'm going to go up, and I'm going to find where that 2,000 crosses the line, and I'm going to go over. I'm going to think about what this y-axis is counting by, because this is 2,000 and this is 3,000. Or that's 20,000. Oh, that's big numbers. 20,000 and 30,000. So this, and there's 5 of these. So it's 10, it's covering 10,000. That means each of these must be 2,000. So this would be 22,000, 24,000, 26,000, 28,000. On Desmos, you can just click on that point also and kind of mess with it until it's the X value is exactly 2,000. And then you can see the Y value is 28,000 also there. So if you just get that point, you can and click on it, you can see it right there on this next to the point. You have to get it exactly to 2,000 though. There we go. There it is. 2,000 and 28,000. So if she prints 2,000 t-shirts, she'll make $28,000. Now, some folks have told me they don't like graphs. So if I wanted to solve this with an equation, here's what I would do. I'd take my equation that I developed on the previous page. I know my x is 2,000, so I'm just going to substitute 2,000 in for x. Five times 2,000 is 10,000. 10,000 plus 18,000 is 28,000. Okay, so I got the same answer by plugging it into the equation as I did with using the graph. Now let's look at this next question. The cost of running her business was $50,000 last year. How many t-shirts did she produce? So she spent $50,000. How many t-shirts does that mean she produced? Let's answer that with a graph first. So I'm looking for 50,000. That's on the x-axis. 50,000 is outside of what I estimated from my domain. So I'm just going to zoom out a little. So that was just an estimate, and that's okay because this is a really, interactive kind of graph. We can zoom out. We can find that 50,000 point. So here's $50,000. I'm going to go over to my graph, and I'm going to click. Find where Y is exactly $50,000. And I see that the number of t-shirts there is 6,400 because the Y coordinate of that point is 50,000. The X coordinate get back to that exactly 50,000. The X coordinate is 6,400. Okay. If I'm going to show that more visually, go over from 5,000 or from 50,000 till I hit the graph, go down. Each of these squares, that line got a little messy there. It should go straight down like that. Each of these represents 2,000 or 200, so it's 6,400. So this point is 50,000, comma 6,400. I ran out of space there. So that's how you can find that on the graph. Let's see how you can find it with the equation. I know that it's $50,000 means 6,400 t-shirts. Ooh, her business took off. Okay. I was pessimistic apparently about her sales or about her production. So let's find that 6,400 number using the equation. This time, 50,000 is a Y value because that's the money. So I'm going to substitute that 50,000 in for Y in my equation. My equation was Y equals 5X plus 18,000. I'm going to substitute 50,000 in for Y. I want to get this x by itself, so I'm going to subtract 18,000 from both sides. And then I'm going to divide both sides by 5. So 32,000 divided by 5 is 6,400. Which is exactly what I expected to get from the graph. I get 6,400 equals x. So you can use the graph or equation to answer this prediction question. That's it. Go ahead and go back through the video to just the parts you need. You don't need to watch the whole thing, of course. And the next section will address point slope form. The next video will address point slope form.